Okay, so now we're going to talk about this constraint. 3x is greater than or equal to 0.6 times x plus y. If you are to work it out, we get 3x greater than or equal to 0.6x plus 0.6y. And if we take both to the other side, we get 3x greater than or equal to minus 0.6x minus 0.6y greater than or equal to 0, because the sign of these two changes when you take them to the left side. These two terms are both x terms, so 3 minus 0.6 is 2.4x minus 0.6y greater than or equal to 0. Now, if you were to solve this by setting this equal to 0, just like I've told you before, set it to an equality so we can graph it. Setting x equal to 0, y would be equal to 0, because 0 divided by the coefficient would give us y equal to 0. And setting y equal to 0, x would also be 0. So we generate the 2 points 0, 0, and that way we know that this constraint will, or this line will pass through the point 0, 0. We know that. But we need 2 points to graph the line, and using our methodology so far, we've only come up with 1 point, the point 0, 0, to graph it. So when you have the right-hand side being equal to 0, so now we have 2.4x minus 0.6y equal to 0 as the constraint that we're trying to graph. This is what you need to do. We already know that that constraint goes through the point 0, 0. We are solving for one more point. The way to solve that is to have one variable on one side of the equality and the other variable on the other side. So you start with saying 2.4x is equal to, take this term to the other side, and you get 0.6y. Now, by plugging values for x and y so that the left and the right-hand side equal each other, we can find another point that goes through that, other points that go through that line, or that the line goes through. So we can just pick at random, we can pick a value, any value, let's say 10 for x. If we do that, then we get 2.4 times 10 is equal to 0.6y. So 24 is equal to 0.6y. So y is 24 divided by 0.6, which is 40. So we have also here solved for the point where x is 10 and y is 40. And in fact, if I were to pick 1 for x, I would solve for it to be 4, or if I pick 5 for x, y would be 20, or if I pick 100 for x, y would be 400. So you can see that we have this linear, because we're working with linear programming, we have this linear relationship between x and y. In this particular application, the relationship is 1 to 4 between x and y. 1 to 4 between x and y. So now we can graph this line. When x is 10, here's 10, 20, 30, 40. When x is 10, y is 40. 1, 2, 3, 4. This is 0, 40, and this is 10, 0. Here's the point, 10, 40, and if I connect the two, now I have graphed the line, the equation. Here's the point 0, 0. Here's the point 10, 40. The line goes through those 2 points. Now we're ready to test for feasibility. Pick a point, any point, either below or above the line. The point 0, 0, of course, if you pick it, it's going to satisfy the equality because it's going to be on that line. But let's pick, for example, this point, 20, 0, or this point, it doesn't matter. If you plug them, plug that point, 10, 0, for instance, in here, then we get 3 times 10. Is it greater than or equal to 0.6 times 10 plus 0? Because this is the point right here that I'm testing. So this will yield 3 times 10 is 30. Is it greater than or equal to 0.6 times 10 is 6? Is 30 greater than or equal to 6? The answer is yes. And so this point satisfies this constraint, and therefore all these points below the line satisfy the constraint. So here's the feasible region for this constraint. Thank you.